Hello, and welcome to the So You Want to Be a Marine Biologist podcast, where we learn about the ocean, share sea stories, and explore ocean careers. I'm your host, Kara Muzia. Let's dive into today's episode. Have you ever wanted to explore the underwater realm but are unsure how to get dive certified? I've got you covered. Head over to marinebio.life/scuba for beginners and grab your copy of my new scuba guide. In it, I cover the different certifying agencies, gear, lingo, and the number one thing to look out for when you're getting certified. This guide will leave you confident in how to become certified and ready to dive in. Head on over to marinebio.life/scuba for beginners to get your copy and get diving already. marinebio.life/scuba for beginners. Hello, mermaids, pirates, ocean lovers, and land lubbers. Welcome to today's show. Question: what do you call a polar bear living in Florida? A solar bear. Why didn't the fish want to play basketball? He was scared of the net. By popular demand, an ocean engineer. Chris Maingot is my guest today, and he is an ocean engineer and physical oceanographer. Growing up in South Florida, Chris always felt at home in the water and, after a slight deviation down the path of pre-med, decided to pursue a career in the ocean. Today we chat about what an ocean engineer is, what a physical oceanographer does, and about some of the crazy ocean phenomenon, including waves underneath the waves. Nature is wild, y'all. Please enjoy. Chris, welcome to the So You Want to Be a Marine Biologist podcast.
Glad to be here.
Yeah. So you have the title of a senior oceanographic engineer. What does that mean? What do you do?
So I do a lot of studies on the ocean, mostly currents and waves, other physical parameters in the ocean, temperature, salinity. And we also do meteorological parameters, measured on the ocean or in coastal areas.
So how do you measure all of these things on the ocean? Are you physically going out in a boat and dipping your meters in, or is these long-standing buoys that you have out there that you're monitoring?
Kind of a combination of both. It depends on, what the project we're working on needs. There's different equipment we can use to measure these parameters. Like you said, buoys, we use a lot of different buoy systems, either surface buoys or even moorings that are subsurface the entire time, so there's nothing on the surface. And then, also, mounting sensors on existing platforms, or like I said, in coastal areas, weather stations, weather towers. And then also, measuring stuff real time where you're actually there on the boat, lowering an instrument off a vessel and, measuring the data in person at the site.
Yeah. So what would force, one way or the other? Why would you use a buoy versus a hand meter? I mean, obviously physically going out into the field is significantly more challenging, both cost and logistically, to get out in the field, right? In a buoy, you can just leave it. So is that one of the main factors in deciding on what method you use?
Yeah, and it depends too on the site you're trying to measure. So if you're trying to measure some parameters in a kind of coastal inlet area or a river, something like that, where you may not want to leave something there for months on end, and you're maybe just trying to get a tidal study. So you would, just do real-time measurements over, a course of 24 hours to get a full tidal cycle. Whereas other offshore areas, some engineering design stuff, they want a full year to cover seasonality. So there could be changes depending on what season it is and the conditions offshore. So they want something that's there for an entire year to get that measurement record.
And where does this data go? What is it used for?
It varies depending, on the client. There's governmental uses, NOAA and stuff like that collects a lot of this data. Engineering companies for designing structures or coastal development A lot of oil and gas companies use this data as well to design their structures and pipelines and stuff like that to ensure that they're going to withstand the conditions they'll meet in the ocean to prevent any issues there. Also, offshore wind energy and renewable energy have become quite bigger users of this data recently. So, wave energy companies as well as a lot of wind energy companies. So for wind energy, they need to do assessments on what the wind speeds are like and, any shear that's there. So we have systems that we put on buoys that can measure a profile of the wind up to about 200 meters height with a laser. So it does not physically any sensors at those heights. It's a laser beam that shoots in the air, bounces off particles in the air, and then it can measure the speed and direction that the wind is moving.
That's crazy. So you just mentioned wind shear. Could you define that?
So that would be differences in the speed or direction of the wind at different heights. So that can create issues for a structure that's varying in those heights. The wind turbine blades, if they have different wind forces acting on them at different levels, it can create stresses.
That's not something you really think about. I mean, some of these wind turbines are hundreds of feet tall, right? And if they have winds going one direction at the top and then other direction at the bottom, that could get interesting. I never thought about that. So something I learned fairly recently, and maybe I learned it in school and promptly forgot it amidst all the things that were stuffed in your brain in school, but there's actually waves underwater. So like we see surface waves and like that's a really obvious one, but then there's actually waves that are subsurface, and that kind of boggles my mind a lot. Like there's haloclines and thermoclines. Is that how those waves are kind of formed or pushed through? Like how are they formed, these subsea waves? And then how often do you see them? I'm assuming your meters would pick these up.
Yes, internal waves, they're called. So basically a wave that travels along a interface within the water. So there can be, a strong difference between salinity between two kind of bodies of water within the ocean. And along that interface, there can be waves that travel along, and those are actually of great concern to engineers and to subsea structures because they can be quite powerful and disturb the bottom or create forces on subsea structures, and kind of interrupt any installation activities. So those can be of great concern to oceanographers and engineers to be able to identify those and measure those. They occur in certain areas of the world, more often in places where you have river discharge, where there can be, big difference in salinity between the surface and the deeper waters. Other areas as well produce these waves. So there's some known hot spots for those types of waves. So in those areas, you'd want to employ specific instrumentation that can measure it. The company I work for has actually their own current meter sensor that they've designed that measures really high frequency currents and is able to do so for long periods of time. And it's actually one of the better sensors to use to measure these internal waves.
That's wild. So when you're measuring these internal waves, are these the subsea meters that you're putting out for long periods of time, and then it's kind of data logging all of that and you check it later?
Yes, yeah, that would be set up in a recording configuration. So we'll deploy it along a mooring, usually a subsurface mooring, so they're not moving. And then, they measure, at the specific depth that we place them at. And they'll be looking for vertical movements in the current.
So I feel like it's probably like an Excel sheet output, but in my brain, I'm picturing y'all watching like a heart monitor, right? But it's a wave monitor on your screen. And it's just going beep, beep, beep. Whoa, big internal wave. Is that what it's like? Or is it just like an Excel sheet with like number of data points?
Yeah, I mean, when we first output it from the instrument, yeah, it's just going to be, some sort of native file with just numbers. But, we process that data, we remove kind of erroneous points or spikes, and then, we plot that data so that it's on a graph. And it's kind of like you said, it's looks like a heart rate monitor, kind of spikes of current, increasing and decreasing. A lot of times you see tidal cycles on there. So you see repeated patterns, on 12-hour, 6 hour scales roughly for tidal influence. Occasionally you get extreme events where you'll have really strong currents or really strong waves. And those are always interesting to see the extreme events.
So all of this data, so for structural planning is kind of what I'm thinking. It just helps you be able to better design the structures that will go in the ocean, or would it just totally deter from a specific site, or is it kind of like a combination?
I mean, it could be either. If the client is considering two different sites to put in a structure, to put in some sort of device, they could see some extreme events at one site that would make it not able to install that, or would make it more costly. So having the data and then being able to know what the extremes are, allows them to optimize their design so they're not over engineering and the equipment costs more than it needs to be. And they're also not under designing and, going to have some sort of catastrophic failure. The data we collect would usually do a year study, maybe 2 years. And then they use that data to calculate extreme events. So they'll do like a 50-year return where they'll take our data and extrapolate basically what would be a 50-year extreme storm or extreme current event. And, 100-year, they have all these different basically year criterias that they create to say, this will be the strongest event we'd expect in 100 years.
And then sometimes nature's like, we'll give it to you now in 100 years.
Yeah. Here's a 1,000-year storm.
Oh, that's funny. So, how did you get into ocean engineering? Why ocean engineering?
I grew up in South Florida around the ocean, fishing and diving and stuff like that. I started off my college career in pre-med at Tulane in New Orleans, and realized that wasn't for me. So I ended up coming back to FAU and doing ocean engineering. It seemed like something interesting, and being able to work around or on the water was more my pace.
Hey, Kara here. I hear it all the time. How do I become a marine biologist? Or my niece wants to help the ocean. Where does she even start? I hear from students, yes, and also nurses, HR professionals, and other mid-career folks who wonder if they could still make their dream of working with sea turtles or sharks come true, wondering if it's too late to answer the ocean's call. Here's what I've learned after 20 years in the field and hundreds of interviews. There's no straight line, no magic degree, and no gatekeeper. You create the path forward. If this sounds overwhelming and vague, I've created 2 tools to help you stop wondering what if and start moving forward with clarity and purpose. The first is my free guide, Be a Marine Biologist Without the Degree. Over 1,000 people have already downloaded this guide and taken their first step towards ocean impact. Inside, you'll find 7 concrete, doable actions to help you get started, whether you're just exploring or ready to make a change. Then there's the Ocean Blueprint. This is a 30-day self-paced course that helps you build your unique path into ocean science and conservation without quitting your job or going back to school. Inside the Ocean Blueprint, you'll get daily prompts to explore your interests, skills, and next steps, a structure that turns overwhelm into real momentum, and a bonus section to root your work into ocean connection. You don't have to wait for a degree, a perfect plan, or permission. Whether you're wading in or ready to take the deep dive, these tools are here to help you move from dreaming to doing. The ocean called. Are you ready to answer? Links in the show notes and on my website, karagracemusia.com. I can't wait to see the waves you'll make. Pre-med is biology. Like, I had a ton of pre-med students in my classes when I was doing, general bio. To make the switch from biology base to engineering base seems like quite the switch, Chris, because that never crossed my mind to go to the engineering side of things. There's a lot more math involved.
Yeah, I mean, I always liked math, but I also like nature and biology kind of thing. So I had interest in both, but yeah, ultimately, I guess math won.
Yeah. So, was there a specific job or project that kind of piqued your interest that you're like, ocean engineering seems pretty cool? Or did you just kind of look at the FAU syllabus for it and was like, that's for me?
Yeah, kind of the syllabus and just, it was kind of a wide array of careers you could do with an ocean engineering degree. So I really just wanted something, work on the water. I think initially I was thinking ports or port management, but kind of the road took me into oceanography, and it's quite an interesting field, and I enjoy it.
So, I want to chat a little bit about your time at FAU. Something that I think is super cool for the ocean engineering program is that y'all have a senior design project. And I mean, it is the definition of ocean engineering. So you're literally making something mechanical, usually go, and then ocean environment. And it's quite amazing. What was your project?
We worked on one that we had an autonomous surface vessel, and then we also had a autonomous underwater vehicle that would follow it via an acoustic link. So that sounds a lot more complex than it was, because budgets for those projects are relatively small. So basically, we had a kayak, and we were able to attach some trolling motors onto it. I had a logic controller that would control the thrusters. We had an obstacle avoidance system that basically used acoustic sensors, kind of like you find on the bumper of every car today now, to make sure you don't hit things. Similar technology to that. The underwater portion of it, I think, was already part of FAU's equipment, so we kind of just added that onto that, to the vehicle. So it was an interesting project. Some of that technology you see being used today commercially. So they have a lot of autonomous surface vehicles, and they're moving towards even autonomous survey vessels, or a vessel will go out and deploy, an autonomous vessel will go out and deploy autonomous underwater vehicles to perform survey missions and then recover them all autonomously. It's a little mind-boggling. So the other class that was there, we had two teams. The other team worked on an autonomous sailing vessel. That technology is basically been developed and is now being used by Saildrone to do some pretty cool things as well. So pretty interesting how, when we were in school, it was kind of rudimentary, but has now been developed to commercial products.
Yeah. Y'all made the prototype and then it just got buffed up. The kayak with trolling motors on the back. I love it. So did you go straight into your master's from FAU?
Essentially, I spent a little bit of time helping out my family business in the Bahamas doing commercial diving, but then eventually decided to do the master's at Nova Southeastern University, which happens to be just a couple miles down the beach from FAU's CTech campus.
Yeah. Why master's? I mean, doing diving in the Bahamas sounds like a pretty sweet gig.
It was pretty good, but yeah, it wasn't sustainable or long-term career. I guess just decided to get into oceanography. Wanted to do the masters there at Nova.
Mm-hmm. Actually, I'm really curious. You said commercial diving in the Bahamas. So, like, you're not taking recreational divers out for charters.
No, this was industrial diving, so under
Okay.
ships and on the platforms out there doing repairs and cleaning and stuff like that.
Oh, that's hardcore diving.
Yep, a little bit.
Oh my gosh, that's hardcore diving. Yeah, because there's no like conditions or whatever. You just get in the water and go. You're probably underwater for quite a long time too.
Yep, yep. And extreme conditions, low visibility, stuff like that. So
Yeah, that's wild. Okay. So you're like, not sustainable as a career, not something I want to sustain as a career. Why oceanography though? Because I mean, ocean engineering, it ties really nicely into it for sure, but it's still a slightly different sphere in the ocean career world.
most of the routes I was seeing ocean engineer graduates from FAU go was either, go to Houston, work for oil and gas
Mm.
company, either pipeline companies or other oil and gas companies directly, or, it was go to the Navy, work for the Navy, usually out of Washington area or, the other shipyard type areas. And that wasn't really a route I wanted to take. So, there was other local coastal engineering stuff I could have done and tried out a little bit, but ultimately I wanted to do something a little different.
Yeah, cool. So your work in your master's is super interesting. You did like had to I went down the wormhole a little bit. SAR, synthetic aperture radar. I had no idea there were so many different ways to measure things with radar and lasers and light. So, could you explain a little bit about what synthetic aperture radar is and do you just call it SAR?
Yeah, I just call it SAR. So it can be satellite based, or they have also like airplane based systems, probably even drone based systems now for smaller scale stuff. But it's basically a radar signal, and the synthetic aperture part is like how that signal is formed.
Yeah. That's what I read was like the synthetic part is in order to get the signal that at the resolution that they want or that they're looking for, it would require an antenna that's, several hundred feet in the air or more, and that's not practical, right? So that's where the synthetic comes in. So how does that work?
So it's kind of just like an electronically controlled signal for the radar, and it bounces that radar signal off the earth, and you get a return signal to the receiver on the system. There's different parameters for different systems, different frequencies they use, different, they call them bands, like C band radar, X band radar, and they will have different properties and different things they measure. Most of the time, it's not affected by clouds or visible or other or remote sensing technologies. You're limited by the visible view, but most synthetic aperture radars are able to see through clouds. There's some instances where heavy rainstorms can affect the signal. You can see that sometimes in the images, but for the most part, they can see through clouds. And a lot of it is used for land-based stuff. They use it for crop monitoring and agriculture because it can help determine the health of a crop or health of a certain area.
Interesting. So applications in the ocean, though.
When the signal bounces off the ocean, the roughness of the ocean, so the small scale, centimeter scale waves, so very small ripples basically on the ocean, kind of what give it the contrast. So you can see features on the ocean surface. And there's various features you can see in these synthetic aperture radar images. Ship wakes are quite easily visible because they disturb the surface. So that was one of the things my professor was working on during my master's degree is measuring these ship wakes and trying to determine properties of the ship or which direction it's heading or other properties like that. But you can also see frontal boundaries where you have maybe currents, especially in the Gulf Stream, which is where we were working. You could sometimes see the boundary between the Gulf Stream and the coastal waters. because there'll be either aggregations of sargassum around there or other things that are affecting the small scale capillary waves, the centimeter scale waves that the radar reflects off of. Also used for oil spill detection because the oil will dampen those waves, so that would cause a contrast in the surrounding area. And there's numerical methods that they use now to determine if it's an oil spill or some other type of feature.
Really cool. So I want to back up for 1 second. You mentioned Gulf Stream, which is western boundary current on the North Atlantic Gyre. So there's gyres in every single ocean in the world. North Atlantic Gyre has the Gulf Stream, and it's a super fast-moving current that runs off the eastern seaboard of the United States. And it's very close to Florida, which is partly why we're so warm. Partly. And then you also mentioned sargassum before I asked that question. So sargassum is a seaweed. It's very common here in Florida. I mean, it's actually a brown algae, but we'll call it seaweed because most people know what that is. But how fast does the Gulf Stream actually move? It's like 4 or 5 knots?
Yeah, it can get up to 4 or 5 knots. There's been, a fair amount of measurements done in there over the years, various different methods of measuring. It can be difficult to measure with moorings just because it's so fast. It can destroy equipment.
Right. And it's deep.
Yeah, very deep.
What is it, like 400-ish feet? How deep is it?
How deep does the current go? Or how deep is the ocean where it is?
Yes, both. Yes, I'm not actually I thought it extended the whole bottom.
No, the Gulf Stream strongest at the surface, and then it kind of tapers off as it gets down, and then actually down deep near the bottom, you actually have a countercurrent that goes the opposite direction. So the Gulf Stream normally flows north along the coast, but the deep waters below it actually are flowing south. So there's a countercurrent below the Gulf Stream. That's one of the things in the ocean some people don't think of is like, oh, the water is moving, all the water is moving the same direction. There can be water moving different directions and opposing. So,
okay. So, I mean, that kind of makes sense. Eddies are a common, fairly well-known phenomenon. I mean, definitely well-known in the marine science world. So like if you have, for example, the Gulf Stream, there's always like little eddies of currents that spiral off and they can go all sorts of different directions. But I always assumed that the Gulf Stream went top to bottom and it was a uniform speed, I guess, throughout. And that's mind-boggling that there's a current underneath the Gulf Stream that goes the opposite direction. That's crazy to think about. So how deep is it, though? I'm like trying to remember. I'm just trying to remember my GPS last time we were out there. It was like 400-ish feet, or am I making that up?
I mean, it can come in almost that shallow, but it's usually out deeper, further offshore, and it varies depending where you are along the coast because it's really close to the coast. South Florida, Fort Lauderdale area is about as close as it gets to the coast, and then as you go up the coast of Florida, the shelf starts to widen and it gets further away, further offshore up along the eastern seaboard.
That's cool. So you were looking at, for your master's, the different, like what you saw in situ versus what this SAR found. So how did you measure that?
So we'd have satellite overpasses, times that we knew the satellite was going to be over our area taking images. And then we'd go out on a vessel and collect current profiles. We'd have a current meter at the side of the boat, and we'd do transects to measure the current just to see if there was any current boundaries, trying to determine where the Gulf Stream boundary was. So if we saw any features in the satellite image that looked like a current boundary, we'd have the corresponding data to correlate that in locations. We were also collecting AIS data, which is Automatic Information System, which is vessel positions.
The big ships.
Yeah, so we'd be collecting all the data on what large ships are in the area. So if we saw ship wakes, we'd know which vessel it was from, size of the vessel, how fast it was moving, all those kind of parameters. And then we were also doing stuff with surfactants, which are essentially oils that dampen the small scale waves that the satellites use to measure. So we were using fish oils. So it was a natural fish oil, and we would be dispersing some of that along the surface or in patterns and seeing how that displayed on the image from the satellite.
Did you ever try to make surfactant artwork, fish oil artwork in the ocean, and then try to see if your SAR could pick it up?
Yeah, kind of like crop circles, do patterns.
Yeah. And like the water dispersed it a little bit. So it's just like a little watered down, little fuzzy edges.
Yeah, I didn't get very artistic with it, but we probably did some lawnmower patterns.
That's fun. So you spent a ton of time playing out in the water, really?
Yeah, it was a lot of time on the water, and because we were coordinating with these satellite overpasses, sometimes it was at crazy random hours in the night, going out at midnight and staying out till 2 or 3 a.m. doing these things. So it was it was an intense sampling period while we were gathering the in situ data.
Yeah, that makes sense. I just assumed in my head you need daylight, but you said it could see through clouds, so it doesn't need light to work.
Yeah.
That had to be trippy, going out the inlet at like midnight. Can only do that certain times a year on certain boats.
Yeah. Yeah. So definitely weather dependent.
Yes, absolutely. Was most of your studies done in the summertime then?
Yeah, I think we try to do most of them in the summer because weather's more predictable then.
Right. Other times of the year. What did you find? How did your in situ data compare to your SAR data?
So so we just compared kind of the frontal boundaries and the oils, fish oils that we were releasing. So it was kind of just a study on identifying those features in the SAR image. So if we took a SAR image where we didn't have in situ data, we could say, okay, this is a current front. This could have been interference from a rainstorm, because we were also looking at radar data during these overpasses as well, so we could identify any interferences. Yeah, and looking at the ships and the ship wake. So basically, so we could translate that into satellite images where we didn't have in situ data, we could more clearly identify what the features we see on those images are.
Cool. When you were graduating, what kind of job were you thinking that you were going to get? Or actually, maybe even because when you're graduating, you're like, a job would be great. So when you're going into your master's, what was like the job that you were like, this is what I could get out of this degree?
Yeah, I wasn't, when I was getting the master's, I wasn't really focused on physical oceanography yet. I was still kind of maybe thinking something in ports or something on that in that realm, kind of similar to the industrial diving. I was doing something kind of in the marine industrial industry, but got involved with the physical oceanography lab at Nova, and became fairly well interested, in the work we were doing, and I really liked the measurement side. The measurements we were doing, measuring currents, and we had a couple of small moorings that we had as well, and I got to interact with a contractor that specialized in the moorings and really kind of enjoyed doing that. He kind of took me under his wing and taught me a lot of that stuff. So, and that's kind of what led me in that direction.
Cool. Yeah, mentors help. They're important. That's cool. Do you use your SAR data or your SAR instruments? I guess that's the word I want. In your current capacity at all?
Nope, I have not looked at SAR data since I was in school. So the SAR satellite images, generally they're for commercial use, they're fairly expensive. at least they were when I was in school, to actually purchase images. We were doing research, so we had grants from the satellite companies. They would give us images, but to use it in a commercial sense would be it's fairly expensive. But there are some companies obviously that use it because that's what they market their data for. But I don't use it directly presently.
Right, because you can get satellite images for significantly cheaper, even though it's not as reliable, because you mentioned cloud cover and all of that can affect the image. Okay. It's interesting. I'm sure that technology will become more affordable as time goes on, because that just seems to be the way of things.
Yep.
Really interesting. So when you were graduating with your master's, were you recruited, or did you, do your shotgun applications and RPS kind of popped up on your radar?
Yeah, I applied. I wasn't recruited. I applied to a few places that do the commercial oceanography stuff, and from some recommendations of the guy I was working with at Nova. So I applied to the company I work for now, RPS. Actually, initially applied for a position in their Charleston office in South Carolina because that sounded quite nice to me, but they kind of switched that on me and told me that position had been filled and they had a position in Houston, which I wasn't too excited about, to be honest, but I ended up accepting the position and moving out to Houston. Yeah, worked out there for 3 years and then, basically decided I wanted to move back to Florida. Luckily, they wanted to keep me around, so I was able to working remotely from Florida, and been doing that for about 7 years now.
That's awesome. Best of both worlds. I mean, so you get to work remotely. So I know there's a fair amount of computer work, right? You have a lot of data to analyze, but how often are you going out on the boats, and where are you going?
Yeah, and that varies. It depends on the projects we have and how busy we are. Larger projects can be up to 160 days a year. I've spent offshore. That's an extremely busy year, but it can be less than that as well. Just kind of doing project coordination stuff in between emails and stuff like that, and managing equipment in between.
What kind of boats are you going out on? Like, I'm assuming these are not tiny boats if you're spending significant chunks of time on them.
Yeah, for the open ocean stuff, it's usually going to be a large supply vessel, at least 100 feet long. Sometimes we get put on client vessels where they're using large subsea construction vessels that have ROVs and heliports on them sometimes, and a lot bigger vessel than we need for what we're doing. But sometimes they have other activities going on, so we just use the vessel they provide us, or sometimes we find the vessel ourselves and make sure it has all the equipment we need on it. Some of the coastal stuff, where we're measuring discharges and stuff like that, will be on really small vessel with just a small over the side system, but those are shorter term projects, obviously.
Yeah, that makes sense. So these boats that have the ROVs on them, I'm assuming there's like other research going on at the same time, or the ROVs just kind of sitting there quietly?
It depends. Sometimes they'll be doing, most of our operations are only done during daylight because we need to be able to see the things on the surface, stuff like that. So sometimes they'll have the ROVs doing work at night to keep them busy.
Do you have to dive at all?
No, not for our work. We try to avoid having to have any divers in the water. And unfortunately, I would like to do diving, obviously, but for safety and hazards, it's better for us to do things without having to put people in the water.
I can imagine putting a single person diver in the water off a 100-foot boat that's used to deploying massive amounts of equipment would be unique.
Yeah.
That's funny. Yeah, I actually helped an ocean engineering senior design project during my undergrad. I got scientific diving certified, and for whatever rule or reason, you had to have a scientific diver to help deploy this buoy. So it was me and Kevin Meyer, who is just like an insane diver. He dives a lot. Anyway, so it was me and another diver, and we were the only scientific divers. And at least he was an ocean engineer. I was not, and I was on the boat with all these ocean engineers, and they're like, and this is you need to do this and make sure it looks like this, and I'm like, okay, here we go. It was fun though.
That's cool.
Yeah, that was very cool. Alrighty, so at the end of each episode, I have a series of questions that I like to ask. You ready?
Yeah, let's do it.
All right. What's your favorite sea creature and why?
Favorite sea creature? That's a good question.
I know. Mine changes by the week, so you could have a couple.
I mean, as a fisherman, I like the delicious ones.
Okay, so what's your favorite one to hunt?
Probably, yeah, favorite one to eat would be a scamp grouper.
Okay.
Quite delicious, and they're not too common.
Yeah. I don't know if I've ever seen one. Okay. What about not to eat?
Not to eat, maybe a nautilus. They're pretty prehistoric and interesting looking.
Yeah, those things are wild. They are wild. Have you seen one?
No, I haven't seen one in the wild now.
That's something I would like to see. That's a good. You're the first person that has said nautilus. That's a good one. That is a good one. What does the ocean mean to you?
That's an interesting question. To me, it's kind of like connections. Like it connects, all different regions of the world, cultures and, connections as far as, trade and transport, as well as personal connections. Like I have a personal connection with the ocean. I enjoy being in it and being around it and, you know, seeing the creatures in it and different processes that happen in it. So it's interesting to me, all the different connections the ocean, brings to us.
That's a good point. It is the great connector, hey? Not to mention like the water cycle and all of that. It's all connected. If you were given a blank check, unlimited funding for any project or projects up to 3, what would you use the money for?
The strict oceanography stuff, honestly, not that exciting or glamorous. So I might delve down the realm of submersible, like being able to go in a submersible and seeing some deep water habitats would be really cool.
Yeah. I feel like there's more and more submersible companies coming out. Actually, I just read I think it was the Boat US magazine. There's some company, I wish I had the magazine here. I forgot the name. It's a German company, and they're building a 120-foot submarine that to take just guests on. It's going to have a restaurant and a gym. Like it's a hotel submarine that they're prototyping and looking for funding for. And I'm like, dang.
Yeah, it's pretty serious. Yeah.
Yeah, that's so wild to even think about. I kind of have mixed feelings on it. But then there's also like Triton submarines, right? They're in Vero Beach, Florida, and they have small personal submarines. And then there's the guy, gosh, is it Belize or Bonaire? A B Caribbean country. He like just made his own submersible. He's like American expatriate and he made his own submersible and he takes people down in it.
Oh wow, that's crazy. I didn't know about that.
Yeah, I'll have to send it to you. I read a book by James Nestor. I think it's called Deep. It's all about free diving and diving, just diving in general. And he goes down with him. And I'm like, that's wild.
Yeah.
So submersibles, personal submersibles. It's an easy one. I feel like you can make that happen. Nick would join you on that. That's like his goal. He's like, I want to go in a submarine whenever I want.
With a blank check, it's possible.
That's right. I like it. I like it a lot. Cool. What is your favorite field story or stories to tell? And this could be an amazing day on the field where you saw all the cool things and everything went right, or it could be a day where things happened and it makes a really great story now.
The good days in oceanography and deploying moorings are the uninteresting ones where nothing goes wrong. There's lots of opportunities for things to go wrong. So the uninteresting ones are the good ones, but there's always some things that go wrong that you have to think on your toes and come up with a solution to a problem with limited resources. So that always keeps you on your toes. And then some of the moorings we deploy, the subsurface moorings, like the way we deploy them, we free fall the anchor so that we deploy the mooring sequentially off the back of the vessel, and we're towing it towards where we want to deploy it, and we deploy the anchor last, and the anchor falls to the seabed and drags all the buoys underwater. So there's an inexact science of trying to figure out where that anchor is going to land, because you want to try and land it, at a target position. So there's, it's a very inexact science, but you can kind of assess what the conditions are that day. And, the way the mooring falls, it falls like a pendulum. The anchor kind of swings back to where your flotation is. So it doesn't just fall straight down. So it's always interesting to me to kind of calculate where it landed and figure out how well I did on calculating where it was going to land. And, I've managed to get a few very, very close to the target location. So that was always exciting to me to figure out how close I landed it.
Got some of that math involved too. I like it.
Yep.
Now, are these subsea monitors, or are they sticking out above the water?
Those ones are subsurface moorings, so everything is below the surface. It's just kind of like a taut mooring line with buoys and sensors along that line, and everything is below the surface.
How do you find it again?
At the very bottom, we'll have an acoustic system, so we can talk to that. We can figure out where it is, and then it also has a release mechanism so that we send it a signal, and it releases the anchor so that the anchor stays on the bottom, and then all the floats will bring the rest of the mooring up to the surface.
Oh, clever.
So then we come by with the boat and pick it up and get it on board.
Yeah, I'm going to say that seems challenging on a big boat to figure out how to get down there and pick it back up, but it comes to you effectively. Cool. Very cool. At the end of each episode, I like to leave the audience a conservation ask to go forth and bring into the world. What would you like my audience to take from your episode today?
Just some awareness on oceanography and, what goes into collecting the measurements, of currents and waves and stuff like that. There's always resources at the various universities that study these things. Woods Hole Oceanographic is obviously a great source for, information. And, locally, Florida Atlantic Harbor Branch has a lecture series they do, which is pretty good, which, gives some insight into the research they're doing and local issues.
That's a good point. Learn more and listen to this episode, right? Learn all about oceanography. If listeners want to find you, connect with you, learn more about you and your work, where's the best place to do so?
I don't really have any big social media presence as far as, outwardly from business or anything like that. I mean, my LinkedIn page, I guess, would be the only thing I could recommend.
I'll put a link to that and everything we chatted about in the show notes. Well, Chris, thank you so much for being on the show. This was fun chatting with you.
Yeah, it's great.
Hey, do you want to help the oceans? Have you considered a career in marine biology, but maybe just aren't sure where to start? Head on over to my website, marinebio.life, and subscribe to my newsletter. When you subscribe, you'll receive a free PDF download where you'll learn the 7 steps to becoming a marine biologist without the degree. Thank you for listening to today's show. I'd love to hear any insight you've gleaned. Leave a comment in the show notes or send me an email over at marinebio.life. If you enjoyed this episode, leave a review and, of course, share with your friends. If you want more resources for ocean news, including conservation topics and careers, plus personal insight from me that I just don't share anywhere else, join me at marinebio.life and sign up for email updates. Keep after your dreams and making waves in your community. One person can make a difference. Thank you so much for listening, and I'll catch you next time on the So You Want to Be a Marine Biologist podcast.